Hello, today we're going to work with solving one-step equations with fractional coefficients. This would also work if we had two-step equation, and this is our guided note. So you're going to notice that you're going to see two methods here. And we're going to start with this method, and I really want you to have your calculator out ready to go. This is more efficient if we have a calculator. And before I start, I just want to review real quickly. If I had this equation, 3x equals 6, then to solve it, because side by side, this 3 and this x side by side means multiply, I will do the opposite operation, which is to divide by 3. So this would allow me to get a 1, and over here I'd have 2, so x would equal 2. So that's how we work when we have whole numbers. Now, using that same concept, we're going to try this when I have a fraction in front. So I'm going to build a wall. And you're going to notice this word complex fraction because we're going to see what that looks like in just a minute. If I have 2/3 x side by side means multiply. So I'm going to divide by 2/3. And just to remind you, any number divided by itself is 1. And on the other side, we're going to have to do exactly the same thing. So when we solve, whatever we do on one side, we do on the other side. Now, let's ignore this right side for a minute. Let's go back to the left side. We mentioned complex fraction, and this certainly, if I look at it, looks complex. And complex fractions are fractions over fractions. So it does look complex. And we're going to recall that this bar, which we use as a fraction bar, also means division. So this is 2/3 divided by 2/3, and any number divided by itself is 1. So I have 1, although it doesn't look like it. I'd like you to take a moment now and put this in the calculator. Would you put 2 ABC, that's our fraction key, 3, and then we're going to press a division key and press 2 ABC 3. Again, that's how we enter a fraction, and prove that it is indeed 1. So pause and do it. When you're done, play this video again. So hopefully you prove to yourself that that is indeed 1. So going back to our problem, 1 times x, there's my x by itself. And then on this side, again, on your calculator, I'm going to ask you to put in 6, which is the top number, divided by, that's this fraction bar right here, and then we're going to enter 2 ABC 3. And pause the video and do that, and then write the answer. And the answer should be 9. So x equals 9. If we wanted to check this, we would start with our 2/3, which is what we're given, x, and we now think that x is 9. And then if we're correct, that's going to equal 6. So again, pause the video and check it, see if that is indeed true. And hopefully it is. So let's go on to the second method. We're using exactly the same problem, but this time we're going to use a method that is helpful when we don't have a calculator. In fact, this method you're going to see in high school. You're going to need to know this even if this is your preferred way. And we're going to do this a couple times. So you get to decide today whether you want to use this method or this method. So let's look at this word reciprocal right here. And if you recall in your past math, a reciprocal is a fraction that is flipped over. And why it's important is if we multiply the original fraction and its reciprocal, it becomes 1. It's also sometimes called the multiplicative inverse. Both of them are just really fabulous, fancy words. So the reciprocal, Mrs. Nord refers to as the refliprical because that's what we're going to do. So in order to solve this, we're going to once again build our wall, and whatever I do on the left side, I have to do on the right side. So this time, in order to get x by itself, I'm going to multiply 2/3 by its reciprocal, which means I'm flipping this fraction over and I'm multiplying it. And if I do it on that side, then I have to do it on the other side. Whatever I do has to look identical. So I'm multiplying by 3 over 2, and I'm multiplying by 3 over 2 on both sides. So that's what we wanted to do. We wanted to make sure they're balanced. Now I'm going to multiply straight across, and I'm going to get 3 times 2, which is 6. And then straight across, 2 times 3 is also 6. And I'm going to drop down the x. Oh, well, 6 divided by 6, there's my coefficient of 1. And the identity property says 1 times anything is that anything. And the anything we're looking for is x. So now we have to deal with the other side. The other side is going to be helpful. Again, you could use a calculator, but if you recall, any whole number we can place over 1. And so 6 divided by 1, or 6 over 1, is the same thing as 6. We're now just writing 6 in fraction form. And the reason I wanted to write that in fraction form is because I'm multiplying by a fraction. So I'd like to have a numerator and a denominator. So we're going to multiply straight across again, and I'm going to get 18, and then 1 times 2 is 2. And if I reduce that 18 over 2, or 18 divided by 2, I get that same 9 that I had last time. So whichever method we use, it's the same. So I know the first time we see this, it's a little bit daunting, but let's go and move on and try this again. Would you please turn to the back side of the page? So at any time, if you'd like to pause and look back at our first example, because I want you to write this down, use it as a reference. So we're going to start again with method 1, which was solving using division. If this was 5x, then I would divide by 5 to get rid of the 5. So this time it's 1/5 times x, so I'm going to divide by 1/5. So we're going to start our solving process. We build the wall. I'm going to divide by what's next to x, because 1/5 is multiplying x. That's why I'm dividing by 1/5. And whatever I do on the left side, I have to show exactly the same thing on the right side. So I know this is not very pleasing to look at. So just so you recall, this left side, if you'll just remember, any number divided by itself is 1. And once again, if you want to prove it to yourself on your calculator, you can. 1 times x would be x. And now this other side is going to take us a little bit of work. So first, clear your calculator, and you're going to take 7. We always start top to bottom, divided by, that's what this bar means, and then we're going to put 1 ABC 5. So 1 ABC 5 is the calculated way to say this fraction, and the result should equal 35. So we think our solution is 35. If we'd like to check it, we're going to take our original problem, 1/5, where x is. We're going to multiply it by 35. We're replacing x with 35. And if you want to take a moment to check that, see if you get 7, pause the video. And it is indeed 7. So let's now do exactly the same problem. We know what answer we're going to get, but let's see what it looks like when we do it the reciprocal way. So we build the wall. The fraction we're working with is 1/5 x, so I'm going to multiply by the reciprocal, which is actually named the reciprocal. So I'm going to flip whatever fraction they give me. In this case, it's 1 over 5, so I'm going to make it 5 over 1. And I'm going to do exactly the same thing on the other side. I'm going to multiply by 5 over 1. So let's make sure our equation is balanced. I'm multiplying on both sides. I'm using 5 over 1 on both sides. So what that accomplishes for us, if I multiply straight across on the numerator and denominator, I get 5 over 5x. And then that gives me 1x, so there's my x isolated. On the other side, I have to do a little bit more work. I have a whole number 7, so I'm going to place it over 1. So now I have a fraction times another fraction. 7 times 5 is 35. 1 times 1 is 1. And 35, any number divided by 1 would be the number that we see on top. So it is the same number. So I'd like you to try one now yourself. Let's look at the bottom problem. And you can decide which one of those methods you prefer. You're the one doing the math, so you get to decide. When you get done, would you look back and see if you agree with the answer? So pause the video and try this. All right. Either way you did it, you should get 10 and 2/3, and this answer might have been a little bit surprising. The last two answers were perfect whole numbers, and it's okay if we get another mixed number or, in fact, a fraction. Thank you for listening, and have a good day.